All right, it is now 1 o'clock, so we're going to go ahead and begin with our program today. Once again, welcome everyone. Thank you so much for joining us today for our Perseids Meteor Show. My name is Andrew, and I am one of the planetarium educators at the Liberty Science Center, which is in Jersey City, New Jersey. So normally, and hopefully soon, I'd be speaking with you from the Jennifer Chalsty Planetarium, the largest planetarium in the entire country, in the entire United States. Today, though, I'm speaking with you from my apartment right outside of Jersey City. We'll be today talking about the Perseids Meteor Shower, one of my favorite events to view every single year during August. We'll be talking about planets you can find during the month of August, as well as some bright constellations and stars you can look for as well. So during the program, if you've got questions for me, you can write them in the comments. There are about 400 of you I'm seeing right now, which is wonderful. We'll try to answer as many as we can. If we don't get to your questions, we apologize. We usually get a lot of questions, so we'll do our best. Helping me out, though, is my colleague Mike, who will be in the comments section answering some of your questions as well. Also, we are getting ready to reopen Liberty Science Center. We're going to be doing that Labor Day weekend. So September the 3rd, we are going to open for our members, and September 4th, we will be open for the general public. So that's when we will be reopening our doors at the Liberty Science Center. Stay tuned soon for more details on new experiences and what will be available at the Science Center when we do reopen. In the meantime, though, if you would like to support us, as Liberty Science Center is a nonprofit, you can do that if you're able to, and if you'd like to, using the donate button, which should be visible somewhere around your screen. I still haven't figured out exactly where it is, so it's somewhere to my right or my left, above me, might be below me. I have no idea. So if you find that donate button, that is a great way to support us and our planetarium on streams. So as I mentioned, we're going to be talking about the August night sky, the Perseids Meteor Shower, planet, stars, constellations. But I did first want to give everyone a really quick update on a really cool thing that happened over this past weekend. So let me go ahead and switch our screens over here. We're looking here at the International Space Station. And several weeks ago, a couple of astronauts were launched on a rocket built by SpaceX, a private corporation, up to the International Space Station. It was the first time that American astronauts were launched from American soil, and the first time that they were launched up to the International Space Station on a rocket built by a private corporation. They made it up there, and 60 days later, after their arrival at the space station, they made their way back down to the Earth. Now, the space station is 250 miles above the surface of the Earth, which really isn't that far. But when you're coming down through the Earth's atmosphere, it can be kind of a dangerous experience. So it's always great to see that these astronauts were able to do that safely. They made it down to the Earth by splashing down in the Gulf of Mexico. We see them as they were splashing down here, their parachutes helping to slow them down as they come in for their splashdown. We can see here the capsule that they actually landed in the ocean in. The astronauts were inside of this capsule right here, and here they are getting checked in on by some doctors, making sure that they're all safe. So these two astronauts did make it back down to the Earth nice and safely, which is always great to hear. Now, in the future, SpaceX is hoping to send astronauts up to the space station, more than just two, and also to send them up for a longer period of time. This was just a test flight, so they were only up there for 60 days. In the future, they'll be able to keep astronauts up there for as long as a year or maybe even longer. So this was a really, really great first test flight for the SpaceX crewed Dragon capsule, with more missions to come in the future. So I just want to give everyone a quick update on how all of that ended up working out. So now on to our sky. Everything we're going to be seeing today will be focused on the date of Tuesday, August the 11th. But almost everything we'll be seeing today, you'll be able to see all throughout the month of August. We're picking the 11th because the 11th is going to be the best day to check out the Perseids Meteor Shower. So this is what the sky will look like really any day in August right around 6 o'clock in the evening. So to see much else though other than the sun, we do need to wait until after the sun has gone down. So let's go ahead and do that for us here. We're going to fast forward through time. We're going to force the sun to set beneath the horizon, and we'll bring out a little bit more of our sky. So we're looking here. We just watched the sun go down in this part of the sky, which means we are facing over toward the west. So that's what this great big red W means. We put up in the sky now that we are now facing toward the west. Now, in this part of the sky, there are a few things that we can look for, a few bright stars. If you've ever been to one of my shows on here before, you know the first thing I'm going to ask you to do is to find the Big Dipper. I'm going to give you a moment, look around at the sky right now, and see if you can find the Big Dipper. Because especially during August, the Big Dipper is a great sort of a guidepost, a great marker to help us find some other bright stars in the sky. And it turns out the Big Dipper is made up of these 7 bright stars, maybe only 6 depending on where you're at, depending on how dark your skies are. These 7 bright stars, which make the shape of a great big spoon. We'll use our imaginations and draw it as this kind of spoon or big, like, saucepan shape. Now, there is a star in the sky right now named Arcturus. It's a really bright star and the brightest star that you can see in the sky right now. And we're going to use the Big Dipper to help us find Arcturus. Now, if you look over toward the handle of the Big Dipper, you peek over toward the handle of the Big Dipper, that handle makes the shape of an arc or a curve. So we're going to use that curve or that arc to help us find our way to the star Arcturus. If we follow that curve, if we arc to Arcturus, we will find this very, very bright, kind of a reddish-orange colored star. Now, Arcturus is one of my favorite stars to find because it's actually a good example of what the sun could look like in about another 6 to 7 billion years. Arcturus is a kind of star that we call a red giant, and these stars are pretty big. Arcturus is about 25 times the radius, the diameter of the sun, and it's a beautiful star to look at. So we can see here the sun put up next to Arcturus for comparison. Now, normally when we see the sun, it looks really bright and it looks really big. But the sun is not that big of a star. It's a very, very average star. It's a really average star. It's not very big, not very small, not very hot, not very bright. It's average. Arcturus is a great example of a star that is bigger than the sun, but it doesn't look as big from the Earth because Arcturus is really, 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 really far away, whereas the sun is the closest star to us. Now, Arcturus is a part of one of my favorite shapes we can find in the sky during the month of August. We can see it right here. Arcturus makes up kind of the bottom of this shape right here. And what does this shape look like to you? What does this look like to you? Now, during the, we can see Arcturus is right down here. During the summer, and during August in particular, I always like to eat ice cream. When it gets nice and hot outside, ice cream hits just perfectly. And this is an example of a kind of shape we can draw in the sky using our imaginations. This is an asterism called the ice cream cone. You can see Arcturus makes up the very base of this ice cream cone. A few other stars around it make up the rest of it. The ice cream cone, though, is not an official constellation. To make that shape into a constellation, we need to just draw in a few extra stars around it. These stars turn this into a great big constellation named Boötes. Now, Boethius in Greek mythology was a herdsman. He was a farmer, and he stands out nice and brightly here in our August sky. We can also use the Big Dipper to find another very important star. Remember, we can use the arc of the Big Dipper here, this curve to arc to Arcturus. We can also use these two stars over here at the end of the bowl to point us to another very, very important star. Drawing this line up into the sky, which we'll go ahead and do right now, that'll point us to a very important, a very famous star called the North Star. Now, the North Star is an important one because it always points north, right? That's how it got its name. The North Star always points our way directly toward the north. So we're going to rotate the sky around to face it a little bit better. We'll draw that line one more time. Using the two stars at the end of the bowl, draw it up until we find that North Star. The North Star, if you use a couple more stars close to it, these two stars here, a few other fainter stars down here, we turn that into the shape of the Little Dipper, with the North Star making up kind of the end of the handle of this Little Dipper. So these are a couple things you can find in the sky. But these are not technically constellations. They're different shapes in the sky altogether. This is another example of an asterism, a shape that maybe we recognize, but that astronomers around the world don't necessarily recognize. But if we add a few stars onto the Big Dipper, we make it into a constellation. That'll look a little something like this. We can draw in some more stars down here, some more stars down here. Now, what shape does this look like to you? We're going to use our imaginations a little bit today. What does this shape look like to you? To me, it kind of looks like a big giraffe, maybe. Maybe a horse. Maybe the neck's not quite long enough to be a giraffe. I asked the same question to a group of students a couple weeks ago, and one of them told me this looked kind of like a shopping cart. If we had a shopping cart that had really, really like long legs on it, I could definitely see that too. Maybe you think it looks kind of like a rocket ship, or maybe some other kind of animal. I'm seeing horse in the comments. Jennifer says it looks kind of like a penguin. Lynn says it looks kind of like a bird. Mike says it looks a little bit like a horse. Buzz also says it looks kind of like a penguin. I can definitely see all of your answers. But this is a constellation, which means it does have an official name and shape, which is a bear. Ursa Major is this constellation's name. Ursa Major just means big bear. So Ursa Major, the brightest stars in it are just those 7 stars that make up the Big Dipper, making it very easy to find. So once you found the Big Dipper, you've pretty much already found it. Now, if there is a big bear, that means there also has to be a little bear, which is Ursa Minor, made up of the same stars that make up the Little Dipper. So Ursa Minor, the little bear, made up of those Little Dipper stars. While we're in this northern half of the sky, if you've been watching very closely, you may have noticed over the past few minutes some streaks of light going across the sky. You may have noticed those. If you've noticed those, you have noticed some meteors. You may have also heard them before as shooting stars. Just 2 names for the exact same thing. During August, and in particular on August 11th, 12th, and 13th, we will be able to observe the Perseids Meteor Shower. So let me kind of exaggerate our meteor shower a little bit to give you a better sense of what the meteors look like. So a meteor shower happens. This one happens every single August. Happens every year during August. Now the best way to see it will be to go outside on the 11th, the 12th, or the 13th of August in the evening. But your best time to see it is going to actually be a little bit later on in the evening. You want to wait until around midnight or 1 o'clock. That's when the meteor shower becomes the most active. It's called the Perseids Meteor Shower. It's named after this constellation over here, which is named Perseus. If you took all of these streaks of light, all of these meteors, and drew them back, they would all look like they're coming from the constellation Perseus. So that's how it got its name. But what exactly is a meteor? What is a meteor shower? Right? I hear a lot of confusion all the time about a few words that all sound, honestly, very similar. So there are 3 words that we're going to talk about a little bit here today. The first one is a meteoroid. A meteoroid is kind of the first stage of a meteor. Right? It's when you've got a rock or a chunk of a little pebble, a little chunk of dust that is still in space. While it's in space, we call it a meteoroid. Once that meteoroid lands on the Earth, we call it then a meteorite. But in between these 2 steps, when the rock is still in space, when it lands on the Earth, the little chunk of rock, sometimes ice, usually rock, that passes through the atmosphere creates the bright streak of light that we've been seeing so far. That bright streak of light is called a meteor. So meteors are caused when meteoroids pass into the atmosphere. If they survive the atmosphere and land on the Earth, we call it a meteorite. Confusing, right? 3 words that sound almost exactly the same, which all mean 3 different things. So the meteors that we've been seeing in the sky are just what we call the bright streak of light that goes across the sky. This happens because we've got a really, really fast moving little grain of dust or a little rock that's traveling through the Earth's atmosphere. This little chunk, or bigger pebble, this rock, traveling through the Earth's atmosphere is moving so quickly, it actually compresses the air. And when you compress air, it heats up. It heats up so much that it begins to light up in that bright streak. That's what's actually happening. You've got a little tiny rock, grain of sand, grain of dust, something around that size, that passes through the Earth's atmosphere. It compresses the air it passes through. It heats up that air and causes this streak of light through the sky. It also usually completely obliterates the chunk of rock, the meteoroid itself. Sometimes, though, the meteorites can land on the Earth if there's a big enough rock. But these meteor showers are completely safe to view. There is really no danger to viewing these events. It's, in fact, one of the most exciting events in the sky of the year. But why exactly does it happen? Right? I mentioned that the Perseids Meteor Shower happens in August every single year. Every year in August, the Perseids Meteor Shower happens. Well, for this meteor shower, we have a comet to thank. In fact, a comet that goes by the name of Comet Swift-Tuttle. We can see here the orbit of our planet Earth and the orbit of this comet, which stretches out really, really far away from the Earth. Every time this comet, over its life, has passed close to the sun, a little bit of this comet kind of breaks apart or kind of evaporates. And it leaves behind this big trail of dust and rocks and little, like, fine grains of sand almost. And it's when the Earth passes through this trail of dust that we experience that meteor shower. Now, the trail of dust lives in the same part of the solar system all the time, but at the same time every year, the Earth eventually passes through it. One thing that's important to mention, though, I am really, really exaggerating the size of this dust trail. Remember, the little particles that make up the trail are very small, usually just like a tiny grain of sand or a little pebble. Really, really small. We make them look big so we can see them. The meteor shower peaks when the Earth in its orbit travels through this trail of dust that the comet has left behind. Those little chunks of ice, little chunks of rock, the pebbles, whatever they are, pass through the atmosphere, creating those meteors and creating that meteor shower. It's going to peak again on the evening of August 11th, 12th, and 13th. Your best time to view them will be around midnight or later on these evenings. So midnight or later on the evening of August 11th, 12th, 13th. That is the peak of this Perseid meteor shower. If you're lucky and you live in a dark sky location, you can probably expect to see anywhere from 50 to 100 meteors every hour. If you, like me, live in Jersey City with a lot of light pollution, you could expect to see maybe 10 to 20 per hour. But if you've got a chance to travel someplace very dark with a nice dark sky to see this meteor shower, I highly recommend it. It's one of the best events that happens every year. If you miss it this year, though, you can still view it next year, or the year after that, or the year after that, and even the year after that. So that's the Perseid meteor shower. It's going to be a really great event that we don't get to see very often, right? This meteor shower comes around once a year. Other meteor showers happen during the course of the year, but the Perseids are a great one because they happen in August, where it's normally pretty warm outside. So we're going to move on in just a moment to talk about some other things you can look for in your sky on the night of the meteor shower and during August. Before we do that, though, I'm going to really quickly check in our comments here and see if there are any questions that we can answer. Let me see. So Diane wants to know, what is an asteroid? It's a great question. So an asteroid is a bigger chunk of rock that is in an orbit around the sun. So meteoroids versus asteroids, meteoroids are just kind of smaller, and they pass, and they're ones that pass close enough to the Earth to go through the atmosphere. Asteroids, though, are larger and further away from us, and they orbit. They're in very stable orbits around the sun. Let's see. So Lori wants to know, are you able to see the meteor shower earlier in the evening, around like 9 or 10 p.m.? So you can see the meteor shower earlier in the evening. You just won't see as many meteors. They'll be harder to see. So you can see the meteor shower around 9 or 10, 11, but the best time will be later in the evening. That's when we'll see the most meteors. But I know, like me, I'm usually asleep by 10 o'clock. So thankfully for those like me who don't want to stay up quite so late, you can still see it earlier on in the evening. The best time will be after midnight, as that's when the Earth is kind of turning into the path of the meteors. Kind of some complicated physics, but that's why. So one very important thing to mention that I just saw someone mention is about the moon. So the moon is going to be up, unfortunately, throughout all of these nights of the meteor shower. So, at least during the 3 peak nights. So the moon does get in the way, unfortunately. The moon is going to be very bright. It'll be rising around midnight. So the moon does kind of get in the way. But still, it'll be still a better time to watch it after midnight, even though the moon will be visible. And the bright light of the moon can kind of overpower some meteors. So the moon will play a factor, but hopefully not a big one. It's unfortunate. So Shelley wants to know, how many meteors will there be in total? So it depends on where you're at. So from any given location, if it's really dark, you can see around 100 per hour. So around 100 per hour. If you're asking total that anyone will be able to see around the Earth, that's a question I don't know the answer to. There will be hundreds of thousands of meteors that appear somewhere in the sky during the whole length of the meteor shower. So there's a lot of them. From any given location, around the peak time between midnight and like 4 in the morning, you can see around 100 per hour. So Trisha wants to know, is the comet visible still? So unfortunately, the comet is not visible anymore from the Earth. It's too far away from us now, and we can't really see it anymore, unfortunately. It's a great thing to see while it was around, but the comet is no longer visible. Okay. So that's a lot of questions. We're going to go ahead and move on now. I'll be checking in, though, later to answer more of your questions. So we just saw the Perseids Meteor Shower, which will be, again, peaking the night of the 11th, 12th, 13th. Best time to view it between midnight and about 3 in the morning. But you can still see it earlier than that, around 9 or 10. But August, all month long, is a great month to look for planets in the sky. And that's what we'll be talking about for most of the rest of the program today. In fact, if you zoom in very closely on the southern part of the sky, all throughout August, we're looking still at the 11th, this will work all during August, we can see 2 very, very bright planets right around 9 or 10 o'clock, right as the sun is going down. The brightest of these 2 planets is this little dot of light right over here. A useful guidepost to help you find this planet is another group of stars that's over here directly to the south. This group of stars here makes up a little shape in the sky that we call the teapot. The teapot is another example of an asterism. It's a part of a larger constellation, though, which is named Sagittarius. So if you can find a teapot shape of stars over in the southern part of the sky, you'll be able to find a really, really bright dot of light. And this will be the brightest dot of light that we can see in the sky. This will be the brightest dot of light we see in the sky. Toward the south, this is the beautiful gas giant planet Jupiter. Jupiter is a beautiful planet. This is what you could see through a telescope if you've got one at home. Jupiter is a big gas giant, so large we could fit the Earth inside of it 1,300 times. It's also, though, surrounded by 4 pretty bright moons, named Ganymede, Io, Callisto, and Europa. With a telescope, or with a good pair of binoculars, you can point them at Jupiter and be able to actually see some of these moons. Now, every night you observe these moons, they will have moved a little bit. They're not always in the same part of the sky. They're not always in the same orientation around Jupiter. They're moons, so they orbit around. So if you've got a pair of binoculars, you can check out the 4 moons of Jupiter as well as Jupiter itself. But I do want to take us for just a moment a little bit closer to Jupiter itself. Jupiter is a huge gas planet, big enough to fit the Earth inside of it about 1,300 times. Jupiter is covered in storms. The largest of them is called the Great Red Spot. In a recent paper that I was reading this past week, is getting to a better understanding of actually lightning storms that happen in this upper atmosphere of Jupiter. Because they happen, but now we're getting a better understanding of why. So there are lightning storms that cover Jupiter. But the biggest storm on Jupiter is called the Great Red Spot. This storm is about twice as big as planet Earth. I mean, we recently here in New Jersey, 2 days ago, were hit by the remnants of a tropical storm, and other parts of the United States were hit by more hurricane-strength winds, a very strong and powerful storm. But this one here is like a hurricane on Jupiter, only it's way bigger, twice as big as the Earth, and this one also has been around for over 400 years. Way longer than any hurricanes or storms can last here on Earth. So, Jupiter will be nice and visible in the sky tonight and every night during August, every night during September, and pretty visible still during October and a little bit into November as well. So plenty of chances to see the planet Jupiter. Zooming back in to this southern part of the sky, we've seen Jupiter right over here. Great thing to look for. Once you've found Jupiter, over to the left of it, you find another pretty bright dot of light. Over to the left of Jupiter, so over toward the east of Jupiter. Find this other bright dot of light right here, which is another bright planet. And it's not just any planet, it is Mike's favorite planet. This is the great big ringed planet Saturn. So Saturn is going to be visible just like Jupiter throughout all of August, throughout all of September and October and most of November. So plenty of chances to see it. Saturn, though, we know best for its rings. And I love the rings of Saturn. Any chance I have to show you the rings of Saturn, I'm going to take it. So we're going to fly really quickly through the rings of Saturn and visit one or two, I guess, of Saturn's moons. The rings of Saturn are incredibly wide. Or incredibly long, depending on your perspective here. We'll put up the Earth for a point of comparison over here. Here's the Earth. And also the Moon over here. The rings of Saturn are so long, their diameter is so long, that they would almost stretch all the way from the Earth all the way to the Moon. So the diameter of these rings is huge, around 175,000 miles. Huge. But the rings of Saturn are incredibly thin. They're only around 100 or 200 feet thick. So they're really thin. From here, though, these rings of Saturn look kind of like just one big solid chunk. But they're not. The rings of Saturn are made up of billions of tiny little chunks of ice and rock. But these rings of Saturn have not always been here. In fact, about 200 million years ago, these rings weren't here at all. At some point, though, a big moon made of ice and rock got too close to Saturn. And Saturn's strong gravity ripped that moon to pieces in these little tiny chunks of ice and rock that we see here. So plenty of stuff going on in here. There's also, though, these big gaps that form inside of the rings. And these gaps are formed, actually, by moons. This moon right here is named Pan. Pan is one of a few moons that lives inside the rings of Saturn. Pan is more massive than the stuff around it, so it creates this big gap in the rings, kind of pushes stuff out of the way, clearing out this big path. Saturn, though, is home to more moons than Pan. Saturn actually has 82 moons that we've found so far. Could have even more. But its largest moon, and the second largest moon in the solar system, is this one right here, named Titan. Titan is an important moon because it's got an atmosphere. It's got an atmosphere to it. Very different from the Earth's atmosphere, unfortunately for us. Titan is very cold, about minus 200 degrees Fahrenheit. So not a place we can go and live. There's no oxygen in its atmosphere, but it is a pretty special place. And in fact, if you are fans of the Avengers movies, the character Thanos is from Titan. In the Marvel universe, at least in the cinematic Marvel universe, Titan is a planet. But in the real world and in the Marvel comic books, Titan is a moon, which was home to Thanos and the race of Titans. So really cool thing to see here. So Titan is the second largest moon in the solar system and the largest moon of the beautiful planet Saturn. While you are outside looking for Jupiter and Saturn, looking for that constellation Sagittarius, while you're watching the meteor shower, if you peek up above your head, like straight up above your head, you'll be able to find probably my favorite 3 stars to look for during the summertime. These 3 stars make up a really big triangle called, well, we see it during the summer. It's a big triangle, so we call it the summer triangle, made up of these 3 stars right here. The summer triangle is made up of 3 stars that go by the names of Deneb over here on the top left, Vega over here on the top right, and Altair down here toward the bottom. These are 3 very bright stars that we can see really no matter where you are. Even if you're in Jersey City or New York City, these stars are bright enough to still be able to be seen. So keep your eyes out for the summer triangle. Look right up above your head, or anywhere from 10 to about 2 or 3 in the morning, they'll be up there. Easy to find. They're very bright. They're even brighter than they look here in our simulation of the night sky, in our simulated planetarium sky here. Now, each of those 3 stars is a part of its very own constellation. The 3 constellations, we'll draw them out here. Their 3 stick figures look something like this. This one in the top left, containing the bright star Deneb, is a constellation named Cygnus the Swan. Right over here. The star Vega is a part of the constellation of Lyra the Harp, which looks a little something like this. The bright star Altair is a part of the 3rd and final of our summer triangle constellations, named Aquila the Eagle. So these 3 constellations, Cygnus, Lyra, and Aquila, are 3 great constellations to find during the summer. But near Lyra, actually more near the head of Cygnus here, right to the left of the head of Cygnus is an object called M27, or the Dumbbell Nebula. This word here, nebula, just means a big cloud of gas. That's all that a nebula is. But this nebula in particular, the Dumbbell Nebula, is one of my favorite objects in the universe. It looks something like this. You can see how it gets its name as the Dumbbell Nebula. See kind of one end of the dumbbell up here, another end down here. This picture here is taken in a mixture of visible light as well as infrared light as well. We see the Dumbbell Nebula. The Dumbbell Nebula used to be a star that was like the sun. This star, then ran out of fuel, and this cloud began to expand away from this star. What's left behind is this tiny little white dwarf here. It's what's left of the center of this star. If you were here last month, we talked a little about the Ring Nebula, and the Ring Nebula is the same kind of object as the Dumbbell Nebula, called a planetary nebula. Now, the Hubble Space Telescope actually zoomed in very closely in visible light at this one little part of the Dumbbell Nebula. We can see these really interesting wispy structures in here. And we see these wispy structures in every single planetary nebula that we observe. And we don't fully know why they exist. This gas kind of clumps together like this in these areas. We don't know fully why this happens, but we observe it in every single planetary nebula that exists. So that's the Dumbbell Nebula. Not a thing you can see with your eyes, unfortunately, but with a telescope, you can find it. Now, we've given you a lot of things to look for so far in the sky, but I did really quickly want to show you one more planet that you can look for in the sky closer to like 1 o'clock or 2 o'clock in the morning. So around the same time that you will be able to see the Perseids Meteor Shower at its best, you can also keep your eyes out for the planet Mars. We're going to move forward to about 2 o'clock in the morning. I know, a little bit past my bedtime, but that's okay. At 2 o'clock in the morning, we can see the red planet Mars. You'll know it's Mars because it looks red, or kind of like an orangish red. Mars itself looks a bit something like this, but this July has been a really important month for our study of Mars. That is because 3 different missions to Mars have launched from our planet Earth during the month of July. The first mission that was launched is an orbiting mission called HOPE, launched by the United Arab Emirates. So HOPE looks something like this. It's the first Mars mission from the space agency in the United Arab Emirates. The goal of this mission is to study better the climate and the atmosphere of Mars. It's an orbiter, which means it's going to simply get to Mars. I say simply, it's really difficult. And then it's going to orbit around Mars, taking pictures and measurements and data of the atmosphere of Mars itself. Later on in July, another mission launched. This mission, we're seeing an artist's depiction of it here, was launched by the China National Space Administration. So this is from kind of the Chinese equivalent to NASA. They launched a mission called Tianwen-1. Tianwen-1 is a really exciting mission because it's got 3 pieces. It's got an orbiter. Like HOPE, it's hoping to study climate and map the surface of Mars. But it also has a rover and a lander. So a rover that's going to drive around on Mars, and a lander that's going to land on Mars and just kind of sit there. This rover is equipped with something called ground-penetrating radar. It's hoping to help us better map the inside of Mars. It's going to be able to look about 100 or so meters beneath the surface of Mars, looking kind of through the crust a little bit. Help us better understand the inside of Mars and how the crust works, what the crust and the soil of Mars are made of. But the third mission to Mars that was launched is a mission launched from the United States, a NASA mission called Perseverance. Let's go ahead and check out the launch of Perseverance.
7, 6, 5, 4. Engine ignition 2, 1, 0. And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
So Perseverance launched, but it still has a very, very long way to go. It won't make it to Mars until February. It launched in late July and won't make it until February. But the Perseverance rover is going to look something like this. It's kind of an artist's animation of it. The goal of Perseverance is to figure out whether or not there used to be life on Mars or whether there could be life there today. To do that, it has a drill, which we're seeing in operation here, which will drill into Mars and pull out a sample of the soil of the surface of Mars. It will then be able to analyze this sample and figure out the composition of that part of Mars. Now, we'll see in just a moment where Perseverance is today and where it eventually will be landing. Perseverance also has a little, kind of like a helicopter named Ingenuity. The first helicopter we've ever sent into space to land on Mars. We'll see that in just a moment as well. But Perseverance is a great mission. It's going to be a really wonderful tool to help us better understand Mars. Here's a bit of helicopter Ingenuity. Now, our friends at NASA would be a little bit annoyed if we didn't mention that Ingenuity here is not the main focus of the mission, and it's just a test. right? The goal of Ingenuity is to figure out how well a helicopter can work on Mars. It's got a very thin atmosphere, which makes a helicopter possible, but a bit more difficult to use. Its goal is to kind of scout ahead for new territory, new places for Perseverance to drive to and to study. So I'm very excited for Perseverance, and to be honest, maybe a bit more excited for Ingenuity, because it's the first time we've ever sent a helicopter to Mars. So, as I mentioned earlier, Perseverance still has a very, very long way to go before it makes it to Mars. It was launched in late July, and right now Perseverance is about 1.5 million miles away from the Earth. We're seeing Perseverance here still inside of what's called its cruising stage. It's kind of inside of its own capsule that is able to kind of propel itself and make adjustments and eventually land the rover. So this is where Perseverance is today, on August the 6th. As time goes by, it's going to finish its journey all the way to Mars. But it won't make it to Mars until February 18th, if everything goes as planned. Then on February 18th, it will go through the process of actually landing on the surface of Mars, which is always an exciting and also kind of scary thing. Not all Mars missions go off without a hitch, but Perseverance, I'm hoping, and I'm pretty sure it will, when it does attempt to land on Mars in February of next year, February the 8th. Now, where exactly is Perseverance, though, going to be landing? Well, it's landing on Mars, but Mars is pretty big. It's got a lot of interesting locations that we would love to study. Perseverance will be landing in a special place on Mars called Jezreel Crater. We're going to fly in very closely to the Jezreel Crater here, in a much closer look at where Perseverance will be landing and the kind of terrain it will be facing. We're going to zoom ourselves in, look at some very high-resolution satellite imagery of Mars. So it might take a moment to load here, as we're getting a really, really close look at the surface of Mars. All right, so here's Jezreel Crater. It wants to land, we want it to land in Jezreel Crater, here in particular, because there is a lot of evidence that Jezreel Crater used to be a lake. It used to be home to water. And on the Earth, we know that water is very important to life. So, if we want to figure out whether or not Mars has life today, what better place to land than somewhere we know used to have water? We can see some of the erosion that happened on Mars from the lake that used to be here. Here we see these big dunes. These are actually kind of these are deltas, actually, very similar to deltas that we find on the Earth. These kind of outflows of water. So Perseverance will be landing here, and we'll be studying the soil, composition of it, and looking for evidence of life here in Jezreel Crater. Because we know very for certain that Mars used to have water. But the bigger question is, what else did Mars have when it had water 3 billion years ago or more? What were the other conditions like? Did Mars have the other things that life needs? That's still a question we don't have an answer to, but Perseverance will help us answer those questions, hopefully, once and for all. But now that we've seen here Jezreel Crater, Perseverance, those two other really great missions that will be getting to Mars around the same time, that those other two missions, Hope and Tianwen-1, will also both make it to Mars in February. It takes that long to get to Mars, no matter what our spacecraft technology is like. But now that we've seen so much today, right? We've seen planets, we saw the Perseids Meteor Shower, we saw some of our summertime constellations. This does bring us now to the end of our program. So I do want to thank you all for joining us today. I will be sticking around for another 5, maybe 10 minutes to answer more of your questions. If you got them, you can type them into the comments. But we hope to see you back here at Liberty Science Center. Our Planetarium Online stream will be live again next Thursday at 1 o'clock. Mike will be talking all about the history of astrology and some of the scientific origins of astrology. So Mike will be talking about that next week. So we hope to see you there. Again, if you'd like to support Liberty Science Center and the Planetarium and these Planetarium Online streams, you can do that using the donate button somewhere near my head. Don't know where, somewhere around here. You can find that donate button if you'd like to, and if you're able to support us, we greatly appreciate that. We will be reopening Liberty Science Center starting on September 3rd. We'll be open for our members exclusively on the 3rd, and then on September 4th, we'll be open for the general public. So we hope to see you at Liberty Science Center when we do reopen early next month. With that, though, let me take a peek at our comments section and see what questions we have. Let me see. So, Renu wants to know, when can we see Comet Swift-Tuttle? That's a great question. Not anytime soon. Let me actually show us the orbit of that comet one more time. So, the orbits of comets are huge. They take, at the smallest, shortest length, hundreds of years, but many of them take thousands of years to make their orbit. Swift-Tuttle is over here. It'll be a good another couple hundred years before we could ever hope to see it from the Earth. So the comet that created the Perseids Meteor Shower won't be visible. It's just too far away. I don't know an exact date when it will be visible from the Earth again, but I know it won't be anytime soon. It's just too far from the Earth and has such a huge orbit. So not really a chance for us to see it anytime soon, unfortunately. But kind of seeing the meteor shower is like seeing the comet, or at least seeing some of the old pieces of it that have broken off. Let's see, so Kit wants to know, how big is Mars? So Mars is about 1/2 the size of our planet Earth. It's not as large as Earth, but half the size. It's also colder than the Earth. It's colder on average than Antarctica. So it's a cold place, a smaller place. Great question. So Anne wants to know, will those 3 Mars missions collide? That's a really great question. So those Mars missions will not collide. There is really no need to worry about that. There's no chance of them colliding, really. Space is really big, right? Space is huge, and these missions, these landers, these orbiters, the rover, are all around the size of like a small car. But when they're in their capsules, they're maybe the size of like a really small house. And space is huge. And they all left at different times, so they're all very far apart from each other. Once they get to Mars, they'll be operating in different parts of Mars, so there's really no chance of them colliding or really interfering with each other in any way. All of these space agencies that send these missions are really great at working together to make sure they don't get in each other's way. So Cindy wants to know the best time to see the upcoming meteor shower. The best time to see the Perseids Meteor Shower from New York, New Jersey, or anywhere in North America will be August 11th, 12th, and 13th. Your best time to see it will be around midnight or later. But it'll still be visible a few days or a few hours before that, around 9, 10, 11 o'clock on those nights. It will be visible, just you won't see as many meteors. But October 11th, 12th, 13th, around midnight or a little bit later will be your best chance to see the Perseids Meteor Shower. So Anne wants to know, where will the three missions be landing in the same place? So they will not be landing in the same place. So the Hope mission won't be landing at all, actually. It'll just be orbiting. Tianwen 1 will not be landing in Jezreel Crater. I don't think the Chinese Space Agency has made it public where it's landing yet. If they have, I'm not 100% sure right now. But Perseverance will be landing in Jezreel Crater. So they won't be landing in the same locations. It's a great question. Suzanne wants to know, at 2 a.m., will we still see Jupiter and Saturn if you're up looking for Mars? So let's actually look back at the sky as it would look around 2 in the morning. It turns out at 2 in the morning, you will be able to still see Jupiter, and you'll be able to still see Saturn. We see Jupiter right here, Saturn right here. They will be very low around 2 in the morning. So when you're out looking for Mars, Mars will be higher up in the sky, way up here. Jupiter and Saturn, though, will be lower in the sky. They'll be very close to the horizon, but still visible. Still definitely visible. Great question, though. Great question. So Sayura wants to know, how do those meteors actually light up the sky? How do they kind of set on fire? So what's causing the meteor is a small piece of rock, usually the size of like a grain of sand or maybe a pebble. And as this chunk of rock is moving, the Earth is moving too. That causes this little chunk of rock to pass through the Earth's atmosphere. It's moving incredibly, incredibly quickly. Thousands of miles per hour. It's moving really, really quickly. This means that when it passes through the atmosphere, the air in the atmosphere can't move to get out of the way. That means the air is actually compressed. And it's a law of nature that when you compress air, it heats up. And this chunk of rock will be moving so quickly, it will compress the air so much that that air begins to glow with that bright streak of light. And in most cases, the meteoroid, the rock that actually that's actually going through the atmosphere, burns up in the atmosphere because it gets just that hot. It gets really hot, thousands of degrees. It gets super hot, super hot. Great question. Let's see. So, Deborah, to answer your question, if I said October 11th, 12th, and 13th, I definitely misspoke. And if I did, my apologies. A meteor shower will be visible in August 11th, 12th, 13th. If I said October, my bad. I misspoke. So August 11th, 12th, 13th. So thank you for picking up on that and for correcting me. Thank you for that. So Christina wants to know, what is my favorite star? That's a great question. I don't know. Probably Betelgeuse. Probably my favorite star. There's so many good ones, though. I like Betelgeuse. The sun's a great one, too. The sun's the most useful star for us, certainly. So Bodhi asks a really, really good question. Does the meteor shower affect the International Space Station? That's a really great question. No, it really doesn't. So the meteor shower, even though there's lots of chunks of rock flying around, space is huge. So the chances of one of them actually hitting the space station is almost zero. So there's really no danger to the space station from the meteor shower. There's really no danger to the space station. Which is good. Good to hear. But yeah, it's hard to realize sometimes just how much space is up there. And in fact, on the International Space Station, to see the meteor shower, you actually look down at the Earth, because you want to be looking into the Earth's atmosphere, which from the space station is looking down. Is kind of confusing to think about. So, yeah, lots of really, really great questions as always. It is 2 o'clock now, though, which means I am running over on my time here today. So I do want to finish up by saying thank you once again to everyone for joining us today. We hope we answered as many of your questions as we can. If we missed your question, we're really sorry. There were around 800 of you in here at the peak, and so many great questions. We can only answer so many of them. If you'd like to support us, you can do so by using the donate button, which is around my head somewhere here, to financially support us if you'd like to and if you're able to. Great way to do that. We will be reopening on September 3rd for our members and September 4th for the general public. We hope to see you back at Liberty Science Center when that happens. Thank you all once again. Hope we have some clear skies for the Perseids Meteor Shower, and have a wonderful rest of your day. Thank you all so much.